You are welcome to Maths Hub S. I am Samuel, your instructor for today. Actually, this channel has been created to help those who have interest in studying mathematics, and we are going to be starting from the very basis. And we know that people have the notion that math is difficult, and it has actually entered into many people's heads. They have it that math is difficult, but we want to prove the other way around, that math is not difficult. Math is very simple, and everybody can understand it if only you want to understand, or if only you have the zeal or you have interest in mathematics. Don't be scared by the variables that we normally encounter when it comes to mathematics. The variables are simply numbers. So I'm going to do my possible best in this channel to make things very simple and very easy for you to understand. So without wasting much time, we start with our very first topic, which is sequence and series. When we talk about sequence and series, every day we have been encountering sequences in our lives, and in a pictorial form. This is what we can relate to sequences in a pictorial form. As you can see here, I have these circles. If I start from the bottom of the circles, we can see that the circles are increasing. So we can see that they are increasing in size, increasing in size. So we have that they are increasing in size from the smallest, and then we have the next smaller, in that order. So they are increasing in size. Now if I start from the top and going down, then we can see that they are decreasing in size. So we have, that is from top to bottom, they are decreasing in size. So we have decreasing in size, that is from up to downwards. And this is a typical example of a sequence. A sequence is a term that is used, or a word that is used to describe objects or symbols that occur in a particular pattern. If we have objects or symbols that occur in a particular pattern, then we can see that those objects are in a sequence. For instance, we can see that the circles here are in a sequence. Likewise, the triangles that I have at the bottom, we have the smaller triangle, then increases to the bigger triangle. From left to right, we can see that the triangles are also increasing. We can see that they are increasing. Then from right to left, then we can see that they are decreasing. From left, that is from right to left, the triangles are decreasing. So pictorially, this is what a sequence is. A sequence represents objects or symbols that occur in a particular pattern. Here the pattern is that the circles are increasing, and we can predict the next circle. If we are moving from the bottom to the top of the circles, then we can predict that the next circle is going to be even bigger than the bigger circle here. So we can predict that because of the pattern, the nature of the occurrence of the circles. And if we are predicting the next circle from top to down, that is the bottom, then we can say that that circle is going to be even smaller than the smaller circle that we have here, right, based on the pattern. So since there is a clear pattern, we can say that these objects are in a sequence. The same way here, we have the triangles are also in a sequence. The next triangle moving from left to right is going to be even bigger than the biggest triangle that we have there. And then if we are moving from right to left, then we are going to have a smaller triangle here, even than the smallest triangle that we have in the pattern here. In mathematics, numbers can also occur in a particular pattern or in a certain way, and when numbers occur in a particular pattern that can be defined by a rule or a formula, then we can say that those numbers are in a sequence. So for instance, if we have in numbers, if we have when it comes to numbers, if we have 2, 4, 6, 8, 10, then continuous. Then let's say we have a different sequence here, 2, 4, 8, 16. If we consider this group of numbers, let's say this is 1 and this is 2. If we consider this group of numbers, the first numbers that we have here, which are 2, 4, 6, 8, and 10, these numbers we can see that they occur in a particular pattern. For instance, from 2 to 4, from 4 to 6, from 6 to 8, from 8 to 10, then we can predict the next number that will come. That will be 12 because of the pattern. Because we can see this is plus 2, so we have here plus 2, plus 2, plus 2, plus 2. So which means that the next number is also going to be plus 2, and that will be 12. So when there is a pattern that we can trace, or when there is a pattern, then we see that those numbers are in a sequence, or they form a sequence. So the numbers that we have here form a sequence simply because they follow a pattern, or they have a rule that they follow, and therefore this is a sequence. Also, if we come to this side, we have 2, we have 4, we have 8, we have 16. This also follows a pattern because we can predict the next number, which is going to be 32, because each term is a multiple of 2. So the first one, which is 2, is a multiple of 2. So 2 times 2, we get 4. Then 4 times 2, we get 8. Then 8 times 2, we get 16, which means that the next one is going to be 16 times 2, which will be 32 here. So the next one is going to be 32. And then it will continue in that order or that pattern. So basically, we've seen that this is a sequence and this is also a sequence because the numbers have a pattern. That is the simplest way to put it for your understanding. The numbers have a pattern, or they have a rule governing them. They are in a defined order. Now let's do further analysis on the first one, which is this. If we look at the numbers that we have number 1, then we have number 2, we have number 3, we have number 4, we have number 5, we have number 6 going. These numbers in sequence, we call them terms. We call them terms. So basically, the number 1, we call it first term. So that will be first term. The number 2, we call it second term. So that will be second term. The number 3 is third term. This is fourth term. This is fifth term. And this is sixth term. So the numbers, we call them terms. Starting from the first one, we call it first term, second term, third term, fourth term, in that order. We are going to denote our terms by the alphabet U, and then the first term we call it U1, Then the second term, we call it U2. Then the third term, we call it U3. Then the fourth term, we call it U4. Then the fifth term, we call it U5. Then this is U6. We are denoting them by this alphabet here. Note that you can denote it by other. This is not always the case. Some books may use other letters, not necessarily the U, but in our case we are using U to denote the terms. So U1 stand for the first term, U2 stand for the second term, and U3 stand for the third term, U4 the fourth term, in that order. Which means that if we come here we have this one to be the first term, this is the second term, this is the third term, then we have fourth term here, and then we have fifth term. I said the first term is called U1, then the second term is U2, the third term is U3, the fourth term is U4, the fifth term is U5, and the term that we are yet to find is called UN. UN is the term that we are yet to find. That is, there are many terms that we can still find, so we denote that by UN, so that UN will stand in for any term at all that we want to find. So here too, we have UN here. Now we are still proceeding from here. If we look at the first sequence, which is 2, 4, 6, 8, 10, and 12, we can see that U2 minus U1, which is the second term minus the first term, is simply 4 minus 2, and that is giving us 2. Then we have U3 minus U2, that is the third term, minus the second term, which is 6 minus 4, is also giving us 2. Then we have U4 minus U3, which is 8 minus 6, 8 minus 6 is also giving us 2. And we can do the same for U5 minus U4. You also get the difference to be 2. So we see that the difference in between the numbers or the terms here are the same. We have 2 throughout, and therefore this difference the difference here is 2, the difference here is 2, here is 2, here is 2, here is 2. This difference is common to all of them, and therefore we call it common difference. Common difference. Denoted by D, small d, common difference. Now, also if we come to this side, if we decide to find a difference here, we will get 4 minus 2. 4 minus 2 will be 2. Then we get 8 minus 4, that will be 4. Then we get 16 minus 8, that will be 8. So we see that the differences are also different, and therefore we say that there is no common difference here. So no common difference. No common difference. There is no common difference here. But if we find what we call a ratio is simply a division. So we are going to divide the terms by each other. So we take this second term and divide by the first term. We can also take the fourth term and divide it by the third term. So we can take U1 divided by U2, and that will be 4 over 2. Then we can also take u3 divided by u2, and that will be 8 over 4. Then we can also take u4 divided by u3, that will be 16 over 8. That is 16 divided by 8. So here we are getting to this place, we are getting to this place, we are getting to. So when we are dividing the numbers here, the terms in the sequence, the second sequence, when we are dividing the terms in the sequence, we are getting what we call common ratio. So common ratio, we are going to call that R. So we have common ratio. When we come to the first one again, and we try to see if we also get a common ratio, we can take u2 divided by u1, and u2 is 4. So 4 over 2, that is 2. Then the next one, u3 divided by u2, that will be u3 is 6 divided by u2 is 4, and that is not equal to 2. So right away here we can see that the first sequence, or this sequence at the left side, has no common ratio, but it has a common difference. And then the sequence at the right side has no common difference, but it has a common ratio. So now we are coming to make our conclusions. Any sequence that has a common difference is called arithmetic progression. You also call it linear sequence. Now, any sequence that has a common ratio is called geometrical progression. Geometrical progression. We can also call it exponential sequence. Exponential sequence. So we stop our classes here for the day, and our next video or our next lesson, we are now going to take arithmetic progression, where we will unpack the formulas in it, and we are going to do it in a very simple way, just as I've started. You have seen that I'm going very slow, and I'm trying to use numbers, so that basic numbers, so that you get the concept right away, and that is how we are going to do throughout. We will continue in that order, and we are going to make things very simple and easy for each and everyone to understand. And others may want it to be very fast, or for me to move fast, but I'll urge that for the sake of understanding, let's go small, let's move slowly, so that everyone will understand. And this is online teaching, and I'm not in front of you where you can ask any question you want, and therefore that's why I'm moving very slow, trying to explain it in a slow way, so that you can also go along with me, so that we all get what we want. Thank you, and see you again in my next lesson. Have a blessed day. Consider subscribing, liking, and sharing if this video was helpful. And please remember to return for the next lesson that is going to be more interesting. This one, I just try to make the differences between linear sequence and that of exponential sequence. So the very next lesson is going to be interesting. Be sure to be back and then enjoy the lesson.